Hello and welcome back. In this video we are going to be talking a little bit more about the read operator, the read functions in Common Lisp, and we're going to have to talk a little bit of history about how programs used to work and why that has influenced our programming languages and our file systems, and why we talk about reading and seeking. These are the unfortunate hangovers from when computers were first built, because computers, when they were first being developed to use stored programs, these stored programs were being stored on magnetic tape. And if you've not seen one of these, audio cassettes used to be all the rage in the 80s and the 90s, the early 90s. I know compact disc took over eventually, but these audio cassettes, they were two reels, and some magnetic tape would pass from one reel to the other, and the tape would be wound on, and that tape would have, either it had been magnetized or it hadn't been, and that was the beginnings of digital computing. And in the 60s and 70s, they kept storing programs on tape. Towards the late 70s, even into the 80s, magnetic tape was still being used. Some of the microcomputers, the mini computers that were in the UK at the time, used magnetic tape drives. But as the 90s moved forward, we developed hard drives, and they became the de facto way, but they were still circular magnetic plates stacked on top of one another with a read arm, and it was still the same basic principle of magnetically encoded data on a platter instead of on a magnetic tape. And so while the mechanics changed, the basic underlying principle was the same. You were reading whether a piece of a material had been magnetized or not. And the reason I bring this up is because we talk about this magnetic tape, we would have to seek to a position, we'd have to wind it forward or back, and some of what I'm going to talk about now refers to that, and you might wonder why. Legitimately so, but that's why. Many programs and many file systems were either built or designed while this was the case, and the terminology just hasn't changed, and a lot of our technology, as modern as it is, it's still based on ideas from the 60s, 70s and 80s. If you're here because of Lisp, and this was first discovered in 1958. So this is an old idea, and we just have to deal with that. So with that having been said, I'm going to introduce to you some new parts of the reading of files in Common Lisp. So we've got our macros that we developed in the last video here. We're not going to use them for this video, but I'm just going to leave them there for your benefit. What we are going to do, however, is we're going to copy this line, and what I'm going to do is I'm going to say let Yep, that's correct. Sorry, just checking my parentheses there. And really, I'm not going to use in, so I'm going to say declare ignore in. Just for now, we're going to get to it later, but Common Lisp would complain that I have declared a variable and I'm not using it. In fact, I'll show you what it'll say. So let's just format t Let me just catch up there. It got a little bit busy. So I'm going to get rid of that. Let's bring that back, sorry, and let's just get rid of that line. There we go. So if I compile this, we get that. Although apparently it's not shouting at me for not using in, so I guess that's okay. What I will do, however, is I'm going to restart the interpreter so we can get rid of all of this and we know that we're in a fresh session. There we go. So let's recompile that again. Alright, apparently it's perfectly fine with me ignoring that. So we have this array of 15 elements that has got nil in it. And what we're actually going to do is we're going to use the function read sequence. And read sequence, because in Common Lisp, open files are treated as a stream, just like in Java, just like in C. There's nothing unique about that. But because they're treated as streams, we can bulk read out of them, and Python can do this as well. You can tell it to read from a start byte to an end byte and it'll figure that out. Common Lisp is slightly different, so we create an array of elements that we want to hold, and then what we can do is this, read sequence, and it takes a sequence, so this is going to be data, because that's where we're going to put the data. And it's going to take a stream, which is going to be in, which is what we've got there. And then we're just going to format out here data. So we're going to save that, and we're going to compile this. So you can see here on the right hand side that we've now actually gotten the first 15 bytes out of our file. So this opening parentheses here is the array that we're creating, so ignore that. What we've got here, these are the contents of the file, so these are the first 15 bytes. Yeah, so that actually equates to the first line. So let's double this and say 30. Oops. There we go. You can see here that this has actually pulled out the first 30 bytes of the file. So read sequence will read as many bytes as it can from the stream and dump it into the array. Now, when you're reading a file, a text file, it's probably not really what you want to do unless you have a specific reason for going in. But if you're dealing with a binary file, perhaps a compressed text file where, well, gzip, for instance, you can write a series of gzip compressed records into a text file, and even though those individual records are compressed but the file is not, gzip will happily treat that text file as compressed. So that is a use case where you might have a file that's made up of binary data, and you might want to know where the first binary chunk begins and how long it is, and just read that out. So if I could create, I'll do this in another video, I'll show how to do that in another video, but what we might want to do is we might only want the first 15 bytes, or we might want 15 bytes, sorry, but not from the beginning. So read sequence will read as many bytes as can fit into its destination array from a stream. But we might not want that from the beginning. So what we can do this file position. So while we have, I need to specify something here. I need to specify a stream. Yep, that's right. So in is our stream. So file position will advance a stream. The read head, again, think of it as a magnetic tape. It will advance the read head, or the file pointer, to byte 15 of the file. And if we evaluate this now, you'll see that this was the first 30 bytes. Actually, yeah, let's say 15 and let's start from 30 because we saw UCL is the end of byte 30, so let's evaluate that again. We'll get the next 15 bytes out of the file, which is in package fit, and it just ends here. So we can tell, because we knew that this was the first 15 bytes, so because this is slightly longer, this is where it ends, so we don't get the end of that word and the closing parentheses. You can see we've got parentheses there, but it just matches this first one as part of the array. So this is how you can advance a file pointer on by using file position. You can go backwards in the file. This is just setting the read head. Again, it's like you're moving a cassette tape forward or backwards. You can stream through it however you like. And this read sequence is like a bulk read. It's much more efficient than doing read car, read car, read car, read car. You just have to make sure that you've got a destination object where you can put the contents of read sequence, and you could put this in a loop if you wanted to. We could read this in byte by byte, I suppose. But this is something I was personally struggling with at first, is understanding how we could, bulk read some data in. I perhaps thought we could start from a position in a file and read up to a certain point, but we need to know how much data we want to read first, and this is how you would do it. So you create a destination, you set how big that array needs to be, which is how many bytes you're going to read. You set your file position to the offset of the stream where you want to start reading from, and then you just read the sequence of the stream into the data. That's really all there is to it, at least for bulk reading. We could perhaps write a macro for doing this, so maybe I'll give that a go. We have time in this video. So def macro. What shall we call this? Let's call it reads, I guess. And this will take a stream. It will take a start offset, and it will take an end, a length. So what we want to do is we'll want to return a list, and we'll say let sym gen sim. As we saw in the previous video, we want to use this gen sim stuff so that we don't accidentally clobber stuff. And we're going to say data. Oh, wait, no. Let's see. Oh, I'm not sure how we would do this with gensim. No matter. We won't get too crazy if we don't have to, so we'll just create this make array. And this will be the length. I do apologise, I was getting ahead of myself on how to write this macro. I'm kind of live coding here now. I've moved away from my notes, and so I'm a little bit I'm going a little bit off script here. So we create our data. We want to advance the file position of stream to be start offset. You know what? I'm going to swap these arguments around. Because I'm going to do this, if I can. So I'm setting it to 0 by default. So if you just want to read the first X bytes from a file, you shouldn't have to provide that start offset, but it's there if you want to use it. So file position in start offset, then we're going to say read sequence. Say data. And we're going to say stream. And all we're going to do is we're going to return data. So I have no idea if this is going to work or even compile. It looks like we've got some errors there. Undefined variable read sequence data stream, undefined variable data. Why is it saying undefined variable data? Didn't like that. Okay, so apparently because we are creating this locally, we don't need the comma, I hope. So let's see. We've got that defined. We're going to say with open file, say in. You know what, I'm just going to copy that line from above. Why am I doing more work than I have to? Here we go. And we're just going to say reads, and we're going to pass in the stream. We want to say 15 bytes. And let's just say we're just going to print this out. So format T, and we're going to copy this into there. I'm not sure if this will work. I'm kind of just, it does work. There you go. So we can say that, and we're going to say start offset. Actually, I'm just going to call it offset. That's probably easier to type. There we go. I'm just going to recompile that. Say offset 15. And we're going to say offset 30. Offset 45. Offset 60. And you can see that it's just going through and, you know, 15 bytes and things like that. It got this far. You know, spaces and line breaks and whatnot constitute as bytes. So there we go. We were able to write a pretty quick reads macro. We could have done it a different way by passing in a file, and it would stream it all for us if we wanted to. Not stream it, read sequence it all if we wanted to. But we don't have to, so let's have a look at this bit. Let's just change this up a little bit, and we're going to see what that expands out to. So macro expand, I'm just going to say reads in 15, and there we go. This is what it expands out into, just to run that let block. So I thought that was pretty cool, and this is a little bit more on how to bulk read something and maybe a little macro just for the fun of it. and in the next video we're going to look at how to write data to files now. So I hope you're all safe and you are looking after yourselves and others. I hope you've enjoyed that. Please like, share, subscribe. That would make a massive difference to me, and I will see you in the next video.